Hello everybody, welcome back. This is Professor Xiao. The purpose of this video is to help you with a specific homework question. The data set in this video is a little special. It's simulated data, not an imported data. Let's look at the Jupyter Notebook. Based on the simulated data, this is the confusion matrix. Notice that the predicted labels are arranged as columns. The actual labels are arranged as rows. This layout is consistent with the format that I recommend to use in the lecture video as well as in the following videos. Make sure that you stick to these layouts. Here, I simulated the data based on the key values of the confusion matrix so that the confusion matrix will turn out to be exactly the same after the data is simulated. Note that I use a random seed 10 to shuffle the simulated data set. As for the imported packages, we only need a short list of these because we are only dealing with the data sets and the model evaluation metrics. All of the functions used here to calculate the model evaluation metrics come from the scikit-learn package.metrics submodule. The confusion matrix again. Now let's calculate the specific model evaluation metric. In a previous video, I demonstrated how to calculate TPR or true positive rate. Here I will demonstrate how to calculate FPR, namely false positive rate. It's important to realize that FPR is not the direct opposite of TPR, even though the name may show that. So don't be confused about that. As I always emphasize, when you hear the word false positive, it's actually describing a negative actual label. And because all the rates metrics focus on the rows, the fact that FPR is actually referring to a negative actual label, it is fundamentally different from TPR, true positive rate, which is describing all the positive actual labels. So these two are not complementary of each other. A complement of FPR would be the TNR, true negative rate. Okay, back to the calculation of FPR. If you remember, FPR is describing the ratio of FP, the false positive, which is the bottom cell of the two cells on the off-diagonal line, because it's one of the false fault classification outcome. So it's the ratio of the false positives of that second row sum, the sum between false positive and true negative, as shown on the screen. So here, the formula is this, if you calculate by hand. Now let's run this, and let me show you the codes for getting this result using programming. And the process is a little more complicated than the case of TPR. Scikit-learn doesn't have a function to calculate FPR directly, but as you know, FPR is one of the metrics that is used to plot the ROC curve. The two metrics that are used to plot ROC curve are TPR, true positive rate, and FPR, false positive rate. So we will make use of the ROC curve function to get two relevant metrics and throw away the third outcome, which is the array of the thresholds. We will get two outcomes. One is the false positive rate, the purpose of this part of the programming, but we will also get the TPR rate. And later we will use that result to again check the results that we calculated earlier in the other video about TPR. So let's run this. Now it's important to understand that the output of the function, they are all lists. They are not scalar. The relevant results are all on the position of 1 with an index of 1. So when I extract the result, I need to use the index 1 to select the relevant number from the list. All else of these codes remain the same as with the other videos. So let's run this. Now you can see that the calculation of the FPR, false positive rate, by hand as well as by using programming from the ROC curve function correspond to each other exactly. So the manual calculation is correct as well as the codes. Since we also got the result of the TPR, we will check again to verify that the recall, aka TPR results calculated in another video, is correct. So let's do that. Here it is the code. I will compare the recall calculated earlier using the recall score function with the TPR value returned from the ROC curve result. And again, keep in mind that the output of the TPR from ROC curve function is a list. I need to use the index 1 to select the relevant result. Let's run this. Again, the recall, or TPR, is 0.973333. It's a very high recall score, indicating that the model is doing well in this metric. This concludes the demonstration about how to calculate FPR, false positive rate, using manual calculation and using programming. I hope you enjoyed this video. Be sure to watch my other videos on other concepts of the confusion matrix. See you next time.